Hello, we are a world drowning in data. So we need ways to describe the data. So we're looking here at data description. A little bit of a review before we get into particular techniques. Recall that we have this thing called a variable, which is a characteristic which potentially changes from person, thing, from one to another. So some examples are height, weight, and so forth. Remember, we had qualitative variables and quantitative variables. Okay, and with the quantitative variables, we also had discrete and continuous variables there. So with these kinds of variables, we have different kinds or different types of data. Now, data is actually information obtained by observing values of a variable for one or more people or things. And so when you think of a variable, it's actually not a number. It's really a function that assigns a number to a subject. So for example, if the variable is the number of siblings a person has, then as soon as that is observed or that function acted on an individual subject, then we get a number. So I have 2 siblings, and so my data point for that variable would be 2. You may have 3 or 4 or 1 or 0, and so we have different values of data there. Now, with the different kinds of variables, we also have different kinds of data. So we have a similar sort of designation there. We've got qualitative data and quantitative data. Okay, so not too surprising there. But the point is, now we have all this data. What do we do with it? What do we do with it? All right, so let's kind of motivate some things. Let's see here. See if I can get this back down. All right. The right size. Okay. So here's an example, and this is actually a fictitious data set. Final exam scores for a physics class. Okay, so we have actually 40 exam scores there. You see 5 rows and 8 columns of data points. So the variable is the exam score, and that variable was observed on 40 subjects or 40 students, and so we have 40 data points. Now if you look at this list of numbers or this block of numbers, it's not particularly illuminating. There's some things you can take away from the data. You can see that no one got a 100, that no one's scored in the single digits, and if you look closely you can see that nobody scored lower than 36. This is the minimum of that data set, and the maximum is 99. But from that, just from looking at the data, there's not a lot that we can glean from the list of data. How did the class do as a whole and this sort of thing? And so what we'd like to discuss here is to consider methods of grouping or summarizing the data. So we want to look at methods of grouping and summarizing the data. And when we do that, we get a better picture of what the data says, the process that generated the data. And this also, in doing this, it provides a basis for analysis of if we see any trends in the data or patterns in the data, then these sorts of grouping techniques can help us get to that point and observe such patterns or trends. Some vocabulary. What we do with this kind of data that's down here is we take this data and we put it into what are called class intervals or categories, and the categories are defined by what's called a lower cut point and the upper cut point. The lower cut point is the smallest value that would go in a class, and the upper cut point is the smallest value that would go into the next higher class. So we have these intervals or these categories here. The midpoint is what you think. It's the middle of a class. The width of a class is what you think, the difference between the upper and lower cut point. Well, how do we find the width of a class, typically we compute the width of the class by taking the maximum minus the minimum and dividing it by the number of classes that we want. There's not a set number of classes that you have to have for every grouping of data. A rule of thumb is, it depends on the size of the data set, but up here I've got between 5 and 20 classes. If you have a smaller data set, you're going to have fewer classes. The larger the data sets and the more spread out the data, you can have considerably more classes. But anyway, so the width of the class is typically computed this way. Now, it's not always computed this way. We're going to look at an example where it makes sense to come up with our own width regardless of what the max and the min are. In our example, we're dealing with scores for an exam, so it makes sense to have widths of units 10, because that's how we often think of grades. Okay, next item, the frequency of a class is the number of observations. So it's just the raw number of observations that fall into a given class. The relative frequency is the ratio or the percentage of observations that fall into a given class. And we think of the frequency distribution and the relative frequency distribution. We're looking at a listing of the classes and their associated frequencies or their associated relative frequencies. Okay, so coming back to this data set, we're going to group the data into classes of size 10. Again, that makes sense given we're dealing with grades. Note that the upper bounds of the classes are exclusive. Okay, so what we mean by that is the observation 60, which let's see if we can find 60 up here. Here's 60. The observation 60 would not go into this class, but it would actually go into the fourth class. Okay. All right, so what we've done here is we've got our data, and we want to, with the data, we want to count the number of observations that are in each class. And so if we look here at the first class is 30 to 40, including 30 but not 40, is how we would think of that. Let's see if we can find the observations that go into the first class. Okay, so here's one, 36, 38, let's see, and there's a 39, and there's, you can scan through it, but there's no other observations that would fall into that first class. And so our frequency for the first class would be 3. For the second class, if you count the number of observations between 40 and 50, not including 50, you'll see that there's 1 observation in that class. There's 8 observations in the third class. There's 10 observations in the fourth class, 7 in the fifth, 7 in the sixth, and lastly there's 4 observations in the last class. Okay, so we have here the class and the frequencies. Now we can look at what's called the relative frequencies. It's just the ratio here. In this case there's 40 observations, so 3 divided by 40, which is 0.075 or 7.5%, is the relative frequency for the first class. Okay, and let's see here, the second class, is a relative frequency of 1 over 40, which is 0.25%. Okay, bear with me for a second. I'm trying to make sure my recording is working here. Okay, it looks like it's going. Okay, so to summarize this table here, the first columns make up the frequency distribution. while the first and the third columns make up the relative frequency distribution. Okay. So just to get a sense of using this, applying this sort of picture here, this is a frequency distribution. How many observations are between 50 and 70? Okay, so how many are between 50 and 70? That would be the number that are in the second, third, and fourth classes. Okay, we're excluding 70 here. So that would be, of course, that would be 1 plus 8 plus 10, or 19 there, are in that many scores are between 50 and 70. How many scores are less than the 60? Okay, so that would be the number of observations in the first three classes. And so you see that's 3 plus 1 plus 8, and so that would be 12 there. Okay, so 12 students scored less than a D on this final exam. So that would be 12 Fs for that exam. Okay, so this table is already telling us a little more information about the data as compared to just the list of numbers here. Next question here, just to have a sense of what the table says. The percentage of scores that's greater than or equal to 90. Okay, well that would be, well the actual number of scores greater than or equal to 90 is 4, but the percentage would be 4 out of 40, or the relative frequency there. So it would be 10%. That would be the percentage. So 10% of the scores were higher than a 90. 10% were A's here. Okay, so this short lesson deals with grouping data, some important terms here, but kind of the final thing that we look at is this idea of what's called a frequency or relative frequency distribution. Very useful way to summarize and get a better picture of what the data is all about.